Hi guys, I hope you're well. Scout went to the groomer today. Oh boy, he's such a pretty boy. Who's such a pretty boy? Hey Scout, who's so pretty? I wanted to show you this transmitter outputting power. Boy, I'll tell you what, guys. It's hard. This light just swamps everything. Tell you what, guys. I got kind of lucky. I found the problem with the transmitter as easily as I did. See, but it was driving me crazy. This transmitter only uses 3 tubes. See, you either have to use an external VFO with the transmitter or a crystal, one or the other, because this VFO only controls the receiver. So, whether you're using this or a crystal, the signal is applied to this tube here. This is a crystal oscillator, or if you're using a VFO, it's a buffer amplifier. The output of that goes to this tube here, which is a driver. The output of the driver goes to the final PA, that sweep tube. It's a TV sweep tube. And yeah, right? It's all very simple. And yet it was not outputting any power. There was no plate current. Using this meter, you can select to look at plate current or relative output power. There was neither, you know. And I want to show you something on my laptop. Okay, hang on. Okay, guys, this is the schematic of those 2 tubes I just showed you. This is the crystal oscillator / VFO buffer tube. This is the driver tube, okay? You know what I do oftentimes? When I'm sitting in my recliner chair in the living room, thinking and thinking about things, I'll look at the schematic. I'll grab my laptop and look at the schematic and do some thinking. And any thoughts that come to mind, I'll jot them down. Troubleshooting hints, troubleshooting suggestions, I'll jot them down. And later, when I come into the radio room here, I'll check them out, right? Well, look at the schematic. Look how this cathode is grounded. Look how this screen grid is grounded. Similarly on the driver tube. Pins, I can't see, 1 and 7. Yep, pins 1 and 7 of those 2 tubes must be grounded. Okay? Hang on, let me show you something. This is my restoration log that I keep. I mentioned it before. Down here at the bottom is where I noted my troubleshooting suggestions. Okay, look at this item here. You probably can't read it, but I'll read it to you. Check V7 and V8 grounded pins from above the sockets. Now, I checked them briefly before from below the chassis, but sometimes it's hard to get a good reading. I wanted to verify that the tube pins were getting grounded from right at the socket. And I checked it, and damn, man, all 4 of those pins that should be grounded were 10 ohms. They read 10 ohms to ground. And when I saw that, I knew instantly that was the problem. Hang on. Okay, I'm going to show you this thing outputting power. I better move this video along. The rig and the frequency counter are plugged into my isolation transformer, which is plugged into the Variac. I'm going to reach over and click it on. I believe when I had this on last, the VFO was running at 2.000 megahertz. Okay, I'm going to click it on. I got my old Nixie tube frequency counter out to see if that one would work, and it does. Works great. Watch it. Watch it. Boom. It's 1 kilohertz high. Scout's here next to me. He wants some loving. Maybe you can hear him panting. That's good boy ASMR. Hi, baby. Blitzen was like that too. When I'd make a video, when Daddy has to make a movie, he'd get jealous too. Scout's flipping my hand up in the air with his nose. So I'm going to reposition you and show you that power meter and that tune control. Okay, one moment. Okay, see guys, this control is labeled tune. It does 2 things. It peaks your receiver front end for maximum signal strength, and it tunes the output of the transmitter to match the antenna. And the way you adjust it is by looking at the plate current, and you tune this, you turn this for a dip in the plate current. You're shooting for minimum plate current. Alternatively, you can look at the relative power and adjust it for maximum power out. That's how you adjust this output section on this HW-16. Oh, you're on an angle. Hang on. Okay, we're on the 40 meter band. The VFO is set to 40 meters. The transceiver is connected to a dummy load. It's really not a transceiver. It's a trans receiver. It's connected to a dummy load. I'm going to key it and turn this control for minimum plate current. And by the way, the RF output level set to minimum. Let's tune for minimum plate current. And there it is. That red line that you see on the meter, when the plate current is that, you're outputting full power, maximum power with this transmitter. Watch when I turn the power control to full max. Boom. So yeah, I'm sorry about that. Let's turn this control, that tune control. You see I've switched the meter to relative power. Let's tune for maximum power. You can see what a dramatic effect that tune control has on the output power. That's why it can sometimes be an easier way to tune the thing. What else did I want? And when you tune for maximum power or tune for plate current, the two should coincide. Minimum plate current should occur at the same point that the power output is max. If it doesn't, that suggests that your output tube needs neutralization. I won't go into what neutralization is now. One moment, let me look at my cheat sheet. Hang on. Okay, guys, kind of a goofy view. What I've done here is I've disconnected the speaker from the rig so you don't have to hear the hideous side tone, because what I do want you to hear is my Yaesu behind me. I've got the Yaesu's feed line just draped over behind this radio, hooked to nothing. And it's tuned to 7150, just like this radio is. I wanted to show you what its keying characteristics are. Man, I'm so thirsty, I can barely talk. Listen to it. That sounds nice, doesn't it? No chirp at all. Oh yeah. Oh boy. Sounds great. So there you go. That's the TX. That's the transmitter in operation. Now I'm going to reposition you and show you something on the laptop again, I think. Yeah, I'm going to show you why those tube sockets we're reading 10 ohms to ground. Okay? Hang on. Okay, guys, what you're looking at here is the underside of the chassis. We're looking at the tube socket. Give me my pointer. Dang it. We're looking at the tube socket of V7, the crystal oscillator / VFO buffer tube. Let me zoom in on this thing. Well, my mouse isn't working. Let me zoom in on this thing. And my camera is not capturing the contrast well at all. But this will work. Give me my pointer. My pointer keeps getting stuck under my frequency counter. See the green arrows? Those are pointing to the tabs, the lugs of the tube socket pins that get grounded. Okay? I'm going to zoom you in a little farther. One moment. See the yellow arrow? That wire right there hooks to a ground lug right up there. Okay? That wire is grounded. I checked it. It's grounded very well. No problem there. I'm going to zoom you in farther. This is a center post. It's a metal center post in the middle of the socket, and that's what it's used for grounding socket lugs. I'm going to zoom in farther on that. Let's take a look. There. Look at this pin lug. It's soldered to that center post. Look at this one up here. You can't see where the lug is soldered very well. Look at this lug right here. The solder job there is questionable at best. Right? But I checked these and I could have swore they were okay. But when I measured that socket from the top, all three of these pins read 10 ohms to ground. When I was doing an initial look-see and the subsequent work on this radio, I wiggled these wires on the various tube sockets, and this thing was, it was not loose. It wasn't just laying there loose. It was attached somehow, probably with rosin. But I took my ohmmeter when I checked from above and I read 10 ohms. I rechecked these, and sure enough, and this connection was bad. It needed to be resoldered on both of those tubes. On both of those tubes, the same situation was taking place. That wire wasn't soldered well at all, and it was stopping that stage from transmitting. Now, I don't know how that radio could have ever worked. I don't know how it could have worked, but that is a classic Heathkit failure mode. You know, it's classic with point-to-point wiring. And the same thing is true of printed circuit board work with a Heathkit. Bad solder joints are a classic Heathkit failure mode. You must suspect every one of them. Right? That's the magic and the mystique and the beauty of a Heathkit. I've got my anti-shake turned on. What I'd like to do is talk about briefly the receiver's performance. Man, I'm whistling my S's again. I have to talk out the side of my mouth. I want to talk about the receiver's, not so much its performance, but its sound. Oh, I was surprised. You know why? Like you, I'm used to this. But just as get rid of the hiss, about drive me nuts. But the sound of this dear old vintage HW-16, I almost said H, like British people do. It's a HW-16. My homebrew rig here sounds far better than that HW-16. Far better. It has RF gain. It has center detented RIT control. It has AGC. It's a hell of a radio. Don't mind if I gloat. I don't mind if I do. But this HW-16, oh boy. See, this past weekend was the CQ Worldwide WPX Contest, CW edition, and the bands were nuts. They were nuts, man. And it was a great opportunity to realize just how awful this receiver sounds. It's a little bit beepy, but then again, so is an Elecraft KX1 and KX2. I've never heard a beepier sounding receiver in my life. Just awful. If I had a KX1 or a KX2, I'd give it away. Oh boy. I know at least a quarter of you out there are Elecraft fanboys and owners.